Hello everyone and welcome to just a final little extra video at the end of this particular topic, something I forgot to talk about earlier, and this is just the idea of square roots. So if you think about if we go back to when we talked about squaring numbers, so just a little reminder. So when we multiply a number by itself, we call this squaring a number. So just a little refresher, something we've talked about in the past. And you may remember we write this as a shorthand. So instead of doing the number times itself, we can write this as the base number from what we learned with indices squared. And this power of 2 just means it's squared. So it's timesing by itself. And what does it give me when I times 5 by 5? That gives me 25. Another example is, for example, realize I just repeated myself, but another example here would be 8 squared, for example. Just did it again. My bad. If I do 8 squared, that is like saying 8 times 8. Now, from our times tables, if you know those, or you can work it out along the way, but I get 64 here. Now, all of these numbers that we get when we times a number by itself. So this 25, this 64, think back to 2 times 2 gives me 4, and 3 times 3 gives me 9. The numbers we get as a result, we have a special name for these. Now, let me move this along quickly. These numbers here, these guys, my 24 and my 25 and 64, are what we call perfect squares. These are very special numbers that we get from multiplying a number by itself. Numbers like 25, 64, 4, 9, 16 we get when we times 4 by 4. And something we can do with these perfect squares is we can apply what we call a square root. So a square root, this thing undoes the squaring of a number. So when we think of a number multiplying by itself, we square it, we get something else. Square rooting something, a number, is the opposite to this. So square rooting means that when we have a number, one of these numbers in the perfect squares family, we can apply what we call a square root, and this tells me what the number was that multiplied by itself to give me that in the first place. So you take, for example, this square root, we draw that like this. This is what we call our square root. And we just pop our number that we want to find the square root of inside here. You can think of it as a little house, and my 16 lives under the roof of this kind of square root. And to figure these out, all we want to do is we say, all right, well, what number multiplied by itself to give me 16? Now, if you know your times tables, you may remember this is 4. So 4 times 4 gives me 16. So if I undo that, so I find the square root of 16, that just gives me 4. The number I multiplied by itself to give me this. So a square root undoes the squaring of a number, and it only works really nicely for what we call these perfect squares. So looking at another example here, if I took, for example, the square root of 81, I'm trying to find the integer, this whole number, that multiplied by itself to give me 81. Now, if you remember your times tables, 9 times 9, so 9 times itself, gives me 81. So the square root of 81, when I work backwards, gives me 9. Now let's do one more just to wrap up this topic, and that's the number 144. To some of you, you may remember this as the biggest number in our times tables, the ones we learn in elementary school. What two numbers, which are the same, multiply to give me 144? Well, 12 times 12, my last two numbers in my times tables, multiply to give me 144. So if I want to undo the squaring, this square root just tells me what that base number is, what that number is that multiplies by itself, to give me 144. And that number, if we know our times tables, is 12. Thank you so much for watching, guys. This concludes our topic. I hope you've enjoyed it. I hope you've learned a lot, and we will be back with another one shortly. But thank you so much for watching. This concludes our prime factorization and introducing indices topic. But thank you so much for watching, and I'll see you in the next one.